All right, in order to fix the problem with Toasty, you need to understand what zones are and how they work. Now, I can give you a classic definition, but it's going to be confusing. It's much easier to show you in code. So here I'm going to write plain JavaScript code in a separate file. This is not part of our project. I'm going to start by defining a zone object. This object is going to have a method called run that takes a callback. So whenever I want to run a function, I can run it inside this zone. Here's an example. Zone.run. Now here I need to pass a function. So we can use arrow function syntax and simply do console.log. Hello world. And of course, in the implementation of the run method, I'm going to call this callback. Okay. Now you might ask, what is the point of this? What benefit do we get from running this function inside a zone? Well, with this approach, I can execute some code before and after this callback function. So I can add console.log before and console.log after. So no matter what function I pass to the run method, with this approach, I can always run some code before and after my function. Now I can take this to the next level and make it customizable. So instead of hard coding this line here, I can let the client of this zone to tell me what code needs to run before the actual function. In other words, I can set zone.beforeTask to a function, and in this function, do the console log. Then in the run method, I can check if we have this before task set, then we can simply call it. Okay. Now we can apply the same technique with the code that we want to execute after our callback. So here I can check if we have a property called after task, then I simply call it. And from the outside, I can set this property after task. We set it to a function that simply logs a message in the console like this. And here's the output of our code in console. So we have before, hello world, and after. The beauty about this zone is that I can give it any function and I will always have some code executed before and after this function. Now you might ask, what is the point of this? What does this have to do with Angular? Well, think of a component. Imagine in this component we have a button. When we click this button, the state of the component may change. At this point, Angular needs to perform change detection, and if the state is changed, Angular is going to update the DOM, and that's why we see the changes on the screen. So Angular monkey patches the functions in the browser and runs them in a zone. This way, whenever we click a button, that code is always executed in a zone. And after the execution of our click handler, Angular will run its change detection. Now let me show you how we can monkey patch browser functions. So let's say we want to monkey patch this set timeout function in the browser. We want to run it in a zone. So first I'm going to get a reference to the original set timeout and call it underline set timeout. Now I'm going to redefine this set timeout function. So set timeout equals, it's a function that gets a callback and a timeout, right? We are redefining the set timeout. And in this new implementation, I'm going to run the original set timeout inside the zone. So zone.run, I pass a callback here. And inside this function, I'm going to call the original set timeout and give it these arguments here, right? So we have redefined the set timeout function to run it inside a zone. Now, if I call set timeout, give it a callback, and log set timeout, let's see what happens. So we have before, after, and set timeout. Now the order is not right because here we're dealing with an asynchronous operation, set timeout. So this function is not executed immediately. So in JavaScript runtime, we have a message queue. Anytime we have an asynchronous operation, a message is placed in this queue. And the JavaScript runtime has a loop. It looks at this queue, pulls a message out, and then it will call the callback function associated with that message. In this case, set timeout. So this zone I have implemented is a super simplified example. And that's why it doesn't have support for asynchronous operations. And that's where zone.js library comes in the picture. So zone.js is an execution context that persists across asynchronous operations. So it's an execution context, which means we can run JavaScript code in this context and execute some code before and after, and it can persist between asynchronous operations. It's an independent library. It got nothing to do with Angular. It's one of the dependencies of Angular. Now, Angular has a class called ngZone, which is built on top of these zones. And with this, it hooks in its change detection after asynchronous operations in the browser. So we have three types of asynchronous operations. Whenever we are dealing with DOM events, like clicking a button, selecting an item from a drop-down list, and so on, we're dealing with an asynchronous operation. When we send an AJAX request to the server, again, we're dealing with an asynchronous operation. And finally, whenever we're working with timer functions, like set timeout or set interval, again, we're working with asynchronous operations. Now, back to this page. When we click the save button, we don't see the toasty. Previously, this worked perfectly fine when we displayed this toasty here in the submit method. But after we move this code inside our app error handler, somehow the execution of the code fell out of the Angular zone. So when we call this error function here, the state of toasty component is changed, but Angular is not aware of that. That's why it didn't display the toast notification. Now note that here we have a timeout of 5 seconds. So somewhere in toasty service, there is a call to set timeout function. As you know, this is an asynchronous operation, and Angular has monkey patched all these operations to run its change detection afterwards. So that means if I click this button and click again in less than 5 seconds, we get the toasty because change detection worked here. Now, how do we solve this problem? We want to ensure that this code is run in an Angular zone. So here in the constructor, I'm going to add another parameter, ngZone of type ngZone. Now you can see this class is defined in Angular/core. Now in handle error, we call this.ngZone.run, just like the run method I showed you earlier. So here we pass a callback and basically put this code right here. Now this code is run inside a zone. And that means Angular is going to run its change detection afterwards. So let's try again. Click, and here's the toasty. Click, click, beautiful. If I wait 5 seconds and click again, there you go. All right, next we're going to look at login errors.